Okay, I made a MOSFET switcher with bidirectional MOSFETs. Today I made two of these, and this one has a 4022 driver chip, gate driver chip up here. I wrote it down. And when you use this type of Hall effect in A1120 LUA, it's normally open, switch is closed. If you use this one, which is A1125 type, it's normally closed, switch is open. So I have this meter over here, and so if I touch the leads to the meter together, it's like a closed switch, right? So there's a resistance there. So I have this meter hooked to the switching of this, which is drain A and drain B, the drain of one MOSFET and the drain of the other. So when I take a trigger magnet, let's just say I have this, and I put it by the Hall effect, boom, see that? Switches on, pull it away, switches off. Put it there, switches on, switches off. So I'm going to go through the components here while my wife is singing to I think Scooter song. Anyways, so here's the Hall effect. It's got three leads. There's a signal lead. This one happens to be purple, and the middle lead's ground, and the one on the left is red. Now Hall effects, they aren't square. There's a flat side to them. This side, when you figure out what the leads are, you put that flat side down. Positive on the left, signal on the right. So here comes the Hall effect into this. Disconnect this. And let's just do the signal. The purple lead goes to here, which is the same as here. Now this is going to hit the driver chip, and it hits it right here. See that? It's the second pin down from the right corner. This is also flipped upside down. I super glued it to the board. Anyways, from what you see from the right hand upper corner, it's the first one down, and that's what takes the signal. This one right here is left blank. This is supposed to be 10 ohms, but I ran out, so I put two 20s in parallel. So you have a 10 ohm resistor before you hit that. And that's the signal from the Hall effect. Now the power supplier to the Hall effect, this red wire, goes to the power supply of everything else here, the positive. And that right here is the kind of the common positive, I guess you'd call it. And it goes to the upper left and the upper right hand pins of the chip, and I just fold them together and put a little bit of solder on them. So I just do that. So these connect. This connects, this connects, this connects, this connects, and this connects. It's all positive. And this connects, which is going to the 9-volt battery. So this silverish wire is the positive lead. So they're all common. You don't hit the MOSFETs with any sort of positive. What the MOSFETs get hit with to turn them on and off is these two leads right here, which is the first one down and the second one down on this side of the driver chip, opposite side of where the signal comes in. And so you connect these two together, and then you put a 20 ohm resistor. I like to put a 20 ohm resistor. Some people wind around a little piece of ferrite and stuff, but you don't want any like hyper ringing or any sort of weird things going into the gate of your MOSFET. So that's what this 20 ohm resistor is supposed to do. It's a 20 ohm. And so this black wire goes to the gate. And now remember, the two gates are together. They've been soldered together because this is bidirectionally connected MOSFETs. And the grounds, the source is also connected together. And then again, the drain is the blue wire and the brown wire, you know. This is the switch right here. This is the switch, on or off. So it's drain A and drain B. Okay, so now you also need to have a black wire, a ground wire from the source of the common sources of the two MOSFETs that goes over to a common ground of the whole circuit. So that's where the ground hooks up, is on the source of the two MOSFETs connected bidirectionally. Okay, so the ground of the driver chip is this end of it. It's similar to the other side where you take both the lower left and the lower right and you fold the pins together. Just put a little bit of solder on there so they connect. So these connect, and this is the ground. So that goes to the common ground, which is also connected to the ground of the Hall effect. So I have a 10 ohm resistor out from the source to the gate. This helps them turn off. I might not really need that because I have the driver chip, but I like to have this kind of as extra security so the MOSFETs don't stick on. And so that's about the circuit here. Trying to look for something else. I put on a little bit of hot glue because so many times these Hall effects get pulled out. And so that's the circuit. So I'm gonna test it right now. Hold on a sec. Okay, let's do a final test with this. Notice it's in 20 ohms and it's open. Oops. Looks like the magnet. I was holding this magnet. Okay, now when I put the magnet close, it turns on. Take it away, it turns off. So, turn it on, turn it off, turn it on, turn it off. And so, of course, what's happening is I have these little trigger magnets that zoom past. So I guess that's about it for everything. These are N-channel MOSFETs. These are 710 volt rated MOSFETs. And oh, I don't think I mentioned this 22K resistor goes across from the power, the positive of the Hall effect, over to the signal side of the Hall effect. 22K resistor across. And then this is a 10 ohm resistor going to the chip, and there's a 10 ohm resistor across the MOSFETs from gate to source. So, okay, thanks for watching.